Okay, well, thank you all for joining. Apologies for being a little bit late. Um, I'll start off just by introducing a little bit about ourselves at EVX. So, primarily, we formed our organisation out of a concern that we were seeing absolutely no risk assessment process around the rollout and operation of EV charging infrastructure in the UK. And we carry out our surveys across a wide range of infrastructure, from filling stations, bus depots, airports. But we also do a lot in residential basement parking. And literally on every single residential basement parking risk assessment we've done for EV charging, we've seen e-bikes and e-mobility become something we have to consider throughout basements and throughout buildings. So it's now something that we actually include across all of our risk assessments. So, as you said, we cover a wide portfolio of structures and a wide portfolio of clients. So we're working for private organisations, and we do a lot of work with Transport for London and also for local authorities as well, in terms of where they're putting EV charging and how they manage risks around e-mobility. So today, I think I've got about 20 minutes. So we're really going to be touching on a lot of issues, but really to just raise awareness around these issues, and kind of give some food for thought for how we progress them later on and come up with solutions. So what we're really looking at today are the challenge and the goal we have around e-mobility, the growth of e-mobility, a little bit on e-mobility related fire statistics. We'll touch on why batteries failed and damaged battery packs. We'll touch on illegal e-bikes, thermal runaway, and then we'll look at the vapor cloud and rapid fire spread, then onto how we make e-mobility safer, and about risk awareness in terms of informing and engaging, and then aggregating the risk through purpose-built facilities for e-mobility. And then we'll just talk a little bit about proximity of walls, because that's something that keeps coming in and coming out. And we see lots of different recommendations about proximity of e-mobility to walls. And then we'll have a summary and then the Q&A. And if we don't have time to answer everyone's questions on the Q&A, as long as you got them in the chat and I have your contact details, I will respond to you kind of individually or through metroSTOR, whatever works best after the event, to make sure that nobody's questions goes unanswered. So if we look at the challenges and the goal, I think when I look at e-mobility and lithium-ion batteries, they become an unacceptable risk when the combination of device condition, behavior, and location creates what we would call a foreseeable high consequence event. And for today's landlords, it's really difficult because you're required to make defensible and proportionate decisions. You need to cut through confusion, fear, and a lot of misinformation. You're under pressure to do something, but I think for a lot of landlords, they're also bound by a fear of overreacting or underreacting. So as landlords and as managers of residential premises, and any premises to be that matter, it's a really difficult environment, especially considering the lack of legislation there is around e-mobility. So if we look at our goal, we're saying, okay, we want a path to safer charging that's going to involve both behavioural and physical changes to how lithium-ion battery fire risk is managed. And that's really going to be through risk awareness, kind of informing, but also offering support and engaging with people who have e-mobility devices. And I guess we want to create safer charging locations in homes, or create controlled charging environments which are safer within buildings. Because I don't think we'll ever be able to escape from the fact that this is very much a domestic module issue, but we may have the ability to aggregate some of that risk. So if we look at the growth of e-mobility, lithium-ion battery devices in the UK, if I just look back at 2024, the British Cycling Association estimated almost 150,000 e-bikes were purchased in a single year, mostly online. If we look at e-mobility, kind of mobility scooters and powered wheelchairs, the UK has approximately 1.2 million currently in circulation. Unfortunately, it's difficult to get hold of e-scooter sales because privately owned scooters actually remain illegal for road use. But what we do know is most e-bikes, most e-scooters, and most powered wheelchairs are actually charged within a home environment. So I did a little bit of a study between myself and my neighbor to get an understanding of kind of the volume of lithium-ion batteries you may have in our home. And it was a good comparison because we're both two adults, two teenagers in our houses. My neighbor's far more tech advanced than we are in our households, so it's quite a good comparison. So if we look at e-bikes and e-scooters and e-mobility, we have none. My neighbor has them. But then when you take into account laptops and phones and tablets and all that, even toys, vapes, and old phones, tablets, and laptops, which we all tend to hoard somewhere in a box or in the attic, my neighbor had 45 lithium-ion battery devices in his home. And as someone who I would say we don't have that many, we still recorded 28. So they are everywhere in our domestic environment in different shapes, sizes, and configurations. So then we had conversations about where devices are charged. E-bikes, because of their size and the fact that people often want easy in, easy out, are often charged as close to the front door as possible. We found that e-scooters owned by children and teenagers are often almost deemed as like their own possession. So we often find them charged in bedrooms. So when we're talking about e-bikes, we often find they're left by the front door because it's an easy in, easy out approach due to their size. If we look at e-scooters, especially owned by children and teenagers, we often find that they charge them in their bedrooms. If we look at mobility scooters, the size of the mobility scooter often drives where it is charged, but we do find them in bedrooms a lot because it's sometimes the last thing you get out of and the first thing you get into if you have reduced mobility. If we look at phones, and this is one of my pet hates, they're often charged by our beds at night. So I continually go around my house at night and unplug my children's phones at night. They don't thank me for it in the morning, but it's amazing. It's a conversation I have probably at least 3 or 4 times a week, the same conversation about charging at night. And laptops, generally they're charged where they're used, but quite frequently find a lot of domestic laptops are actually never unplugged. People just leave them in, plugged in permanently, which is always very bad for the battery. So if we look at some fire statistics, if we look at London Fire Brigade statistics, we can see e-mobility related device fires are just going up and up and up. So 7 in 2017, and we had 206 in 2025. And we've also had 5 related deaths since 2023. Most of these incidents are actually linked to indoor charging. If we look at some wider statistics, so QBE, who are a global insurer, they use the Freedom of Information request to gather UK data regarding battery fires. And as you can see, it's doubled since 2022. In 2022, we had about 690 that were recorded. And in 2024, that had gone up to over 1,300 battery fires. Bearing in mind, these are the ones that get reported. We still believe there's a lot of fires that actually don't get reported. And e-bikes accounted for 27% of every lithium-ion battery fire in the UK. So we know it's a growing problem. If we look at Europe, it's the same. There's a clear pattern of multiple fatalities from 2022 onwards. And what's concerning is they're typically concentrated in dense urban housing environments. So why do lithium-ion batteries fail? When a device of a battery pack enters something called thermal runaway, it's failing as a result of one or a combination of the following reasons. It's often overcharged. People often use incompatible chargers. There's been physical damage to the battery, which can be hard. It's sometimes hard to see that. They can be poor quality manufacture or design from the start. And we find a lot of people are doing modifications on battery packs, and they're actually quite inexperienced to doing it. So they may buy a battery pack, they want to modify it, they want to make it bigger, they'll go onto YouTube, but it's primarily something they've actually never done before. So what does a damaged battery pack look like? And this is where it becomes difficult, because if you're a landlord, it's quite difficult. It's not obvious to see what a damaged battery pack looks like. So we often say to people, you know, if you can put up informational communications showing people what bad looks like, it might make them more attentive in looking at their battery packs throughout the life of the e-mobility scooter. So typically, any burning or discoloring or rusting around the charging portal, that's a clear indication there's something wrong with the pack. Any swelling of the battery pack, which normally manifests itself as a widening of the casing, is a clear sign that battery pack is in a distressed state. The dropping of battery packs, even a small dent or a dint like this, can actually mean there's damage to a cell within the battery pack. And if you're one of those people who likes to take battery packs apart, then you can quite easily see, once you've taken the cover off, what damage looks like within the battery pack itself. So I'll also quickly touch on what an illegal e-bike looks like as well. And really, one of the key things we say is look for additional battery packs. If someone buys a certified e-bike, it typically comes with one battery pack attached to it. So we can see on this one here, this one has 3 battery packs on it. So we know it's been modified. And be aware of e-bikes that move without being pedaled. If someone's operating an e-bike only by the throttle and not by the pedals, that's actually illegal. A legal e-bike can only engage the motor if the pedals are being pedaled by the person, not just by the throttle. So we're talking a little now about thermal runaway, this is when the battery critically fails. So it all happens, it all starts with one cell. So if you can imagine, a battery pack is just a whole bunch of small batteries, normally slightly bigger than AA size, put together. And one of them, for any of the reasons we've said, damage, overcharging, or even a manufacturing defect, has a problem and goes into thermal runaway. It starts to get warmer and warmer and warmer. And the knock-on effect of that is it warms the cells around it. And eventually, the initial problem cell will start to smoke and emit what we call an electrolyte gas. That will then ignite. Sometimes it can ignite in the form of fire. Sometimes it will actually ignite in the form of a vapor cloud before the explosion. And then, as I said, the risk of explosion and ongoing fire. So it's a chain reaction that can start with just damage to a single cell within a battery pack. And under a thermal imaging camera, it looks something like that. You can see the spread of the heat throughout the battery pack until we get to the point of critical failure. So if we're looking at this in real life, what does it look like? Typically at the beginning, we get an emission of toxic smoke. We get a lot of hissing, popping, and crackling. So there's audible and visual signs towards it. Then when that smoke ignites, we get jet-like flames. We have the potential for explosion. We have an exceptionally rapid fire spread if there's any combustible or flammable material nearby. And we have a risk of reignition. A lot of people say, or a lot of people ask the question, how long does thermal runaway take to activate? Well, it's very difficult. Off-gassing to explosion or fire, it can be hours, it can be minutes, it can be seconds. In some bigger vehicles, such as cars and buses, we've actually seen it take days to occur. So there's no hard and fast rule about, as soon as I see some smoke or hear some popping, how long have I got until I have to respond to the fire? It's really important to remember that thermal runaway is what we call an exothermic chemical reaction, which is extremely difficult to stop once it's started. So most fires operate within something that we call the fire triangle. So if you take away the energy source, you take away the heat, or you take away oxygen, the fire stops. A lithium-ion battery generates its own oxygen. So it operates outside of the normal fire triangle, which is why the majority of fire extinguishers simply will not work on a lithium-ion battery fire. We'll talk a little bit now about the vapor cloud and rapid fire spread. Now, if we look at the media, everyone tends to talk about fire, fire, fire. My primary concern with any form of lithium-ion based battery fire, whether it be a laptop, a bike, or a car, is actually around the vapor cloud. And the vapor cloud contains lots of quite nasty chemicals. But the one I'm going to focus on is hydrogen fluoride, because it typically makes up about 49% of the vapor cloud. So hydrogen fluoride is a very, very aggressive chemical. It will pass through clothing and standard PPE absolutely instantly. It's readily absorbed through the skin and mucous membranes, so your mouth, your nose, your eyes. It will cause blindness, and it causes fluid accumulation in the lungs. So hydrogen fluoride is kind of, in some ways, it's similar to the old World War I mustard gas type toxic. It's important to remember that children and infants are far more susceptible to the effects of hydrogen fluoride because they actually have a bigger surface area to body volume. So they'll absorb more quickly compared to the volume of their body. And it actually requires an antidote. It's a toxin. It's not like carbon dioxide, where if you drag someone to fresh air, they'll start to slowly recover again. You actually have to be physically injected with an antidote because it is a toxin. It's an actual poison towards the body. So as you can see, it's quite a nasty substance, a very aggressive substance. So it will burn, it will pass through skin, but it especially goes for the mucus-producing membranes in the body. I'll talk now a little bit about rapid fire spread and why this is such an issue in the domestic environment. Because domestic homes, and for that matter, offices as well, are filled with combustible materials everywhere. And typically a lack of space creates very, very close proximity between the heater source, being the battery and thermal runaway, and fuel. Burning debris can also be projected from the battery pack over 20 meters. We've seen the shells, the cells fire out of battery packs under pressure. So, you can be igniting something just 20 meters away from where the actual fire started. And of course, if charging is supervised, so especially at night, if there's a lack of smoke detection, that rapid fire growth is allowed to grow quite significantly before any action is actually taken. So how do we make e-mobility safer? First of all, I think we need to look at what can we really influence. So if I look at e-bikes, e-scooters, and mobility scooters, we probably have the ability to influence behavioural awareness, but we probably can also provide some physical infrastructure or to help people charge more safely. When I look at the other items such as laptops and phones, toys, chargeable accessories, yes, we can always try and educate people, but it's difficult to actually provide something in every single home that would physically help them. For example, no one's going to put every single battery-operated device they have in a box at night when they're not using it. There are certain things that are just unpractical. So we need to increase risk awareness to promote good charging habits, because a lot of the problems we actually have come from bad charging habits because people actually don't know that there's a right and a wrong way to charge your battery and maintain battery health. In residential buildings and premises, we should maybe identify and quantify high-risk locations as well. Not everywhere carries the equal risk. We might be able to employ some minor home adaptations and improvements as well. And we might be able to aggregate risk through purpose-built charging facilities. So if we look at informing people regarding risk awareness. Now, there's some great information out there at the moment. We're seeing more and more of it being produced in a very simple format regarding, how do I do things safely regarding charging vehicles, bicycles, even larger commercial vehicles. But we need to understand that no one's going to read a manual. The message has to be kept very, very simple. Where possible, we always say use visual guides and supply a consistent message. And consistent messaging is important because if I pick up the recommendations from 5 different insurers and I read them, I can guarantee you I'll probably have at least 3 or 4 conflicting sets of information. So keep it simple, keep it consistent. And if you can provide that information, it's actually then a tool for driving engagement, where you may be able to offer more support and advice to each person with an e-mobility device. And again, simple examples. This is actually installed by Amazon. So Amazon are now electrifying a huge portion of their fleet. So they have hundreds and hundreds and hundreds of Amazon vans. If you've ever seen the way they're driven, you can guarantee most of them are a little bit damaged somewhere. But really importantly, they stress to their teams. If a fire starts in an electric vehicle, don't attempt to fight it. Clear the area and call 999. So really nice, simple, clear message for their drivers driving electric vehicles. So 6 essential habits that are really good to teach people who have e-mobility devices are always, never charge while sleeping. And I know everybody does. It's a hard habit to break, but it's actually the worst time to charge everything because you're not going to know if there's a problem. Use the original manufacturer's chargers only. I know I'm a real stickler for this. So if I lose my cable or if I lose my plug, I could easily buy one online for a few pounds. It does cost me more money to buy the original manufacturer's one, but it is designed for that piece of equipment that you are charging. Check the battery before, during, and after charging. It's a bit of a pain, but it's always good. Just, pick it up. You will be able to feel it if it's getting warm or if the charge is getting warm. It's one of the very simple things to do. Don't store or charge near any only means of escape. Always charge away from flammable or highly combustible materials. And always charge in a room or an area with a smoke alarm. Then we try and talk to people about the 6 early warning signs. And again, this is an example of what someone has visually done here, which we found very useful. Swelling of the battery pack or cracked casing. This is an early warning sign that something's wrong with the battery. If the battery pack or charger becomes hot, again, early warning indication. Strange smells during use or charging. Damaged wiring. Slow charging or a rapid discharge of power. So almost if the battery pack takes forever to charge or loses its power very quickly, it's telling you there's something wrong with that battery pack. And leaking fluid. Some battery packs will actually leak the electrolyte liquid fluid if they're damaged. And then we talk about the 6 essential responses. Now, obviously, these will change depending on the nature of the type of the building. But we always say to people, don't stop to film it. It's amazing. We've had so many vehicle fires and car park fires recently where it's been over 15 to 20 minutes before anyone's called the fire brigade, yet hundreds of videos have appeared on social media before the fire brigade have even been informed. So don't stop to film it. Don't attempt to extinguish it as well. I say to people, anything smaller than a scooter, if you know what you're doing and you're trained to use a fire extinguisher, you may have a chance of dealing with it. Anything above that, forget it. And most people aren't trained in the use of fire extinguishers. Lots of people will have them in their kitchens. Lots of people will have them in their homes. And the time they pick it up will probably be the first time they evacuate immediately. Of course, in residential buildings, you will have policies around that. A lot of the commercial premises we look at, especially things like bus depots, we just say, get out. Close doors behind you if you're evacuating, slow down the spread of fire. Call your emergency services as quickly as you can. This is critical. And, let people know. Just, don't run out of the building without informing colleagues or people around you the reason why you're leaving their building as well. So this is all about, informing. So now we start to talk about engaging, because people are creatures of habit and they're typically driven by convenience, and this drives their charging habits. If you just tell people, they often forget. People are busy. They don't always remember things. You tell them something on one day, the next day they've forgotten it. But if you offer them something, then they're often more likely to engage. So possibly helping to define a dedicated charging place, or helping them to identify a safe place to charge, in their home, is a good way of engagement. Or sometimes looking at creating some infrastructure around domestic charging as well also helps. So people feel like they're getting something back in terms of their engagement. So we had a little look at some kind of plans of a classic kind of layout of a high-rise residential apartment. Yeah, 2 bedrooms, bathroom, living area and kitchen. And we kind of said, okay, if I was given this area, where would I probably charge my e-bike? If this was my house, I would probably charge it in the living room or the dining room underneath the smoke detector. So engagement can help people identify a safer place to charge. It's about reducing the impact. You're never going to reduce the risk because you don't control what happens on a day-to-day basis, with that e-bike or with that e-scooter. So it's about reducing the impact of something going wrong. And, the difficult reality is it's often a selection of the least bad location when you come to apartment buildings. If you look at them from a pure safety aspect, you would say, actually, you can't charge in here, but that's just not practical in today's environment. For some clients, we helped them define, and we had conversations around lockable plugs. You may have plugs in communal areas that will be very tempting to plug something into and charge, but you don't want someone to plug into it and charge. Often they may be used by equipment for the cleaners. So you can have lockable options on plugs. So you can only use that plug if you're a key holder. We've often also talked to some of our clients around plugs with timers on. So we worked with one police force who built an EV charging area for their e-bikes. And typically the e-bike needed four hours to charge, but they were finding that they were getting plugged in and sometimes left a weekend, on charge. So we look at them and putting in timing solutions. So they plug in the bike, it charges it, gets 4 hours of power, and then it shuts off because that would be enough. So you're not just relying on the battery pack itself, you're relying on another set of controls. And then I'll talk about aggregating the risk through purpose-built facilities. Do not allow the storing or charging of e-bikes or scooters to be random in a premises, because they will just turn up absolutely everywhere. Be realistic about how you implement policies. So we don't allow e-mobility devices in our premises. We hear this so many times, and I'll go into those premises and I'll find the chargers on the floor, and I'll find e-bikes padlocks to various different parts of the building, even though that they have a zero tolerance policy. So if you want to go zero tolerance, really check how enforceable it really is, because they're very nice words, but very, very difficult to actually implement. So there's a lot of purpose-built units available now. So lots of e-bike, e-storage systems, from specifically designed ones to ones that have kind of been manufactured by the user themselves. Key things we often ask people to consider is secure communal facilities allow for a more controlled charging and storage environment, opposed to spreading the risk throughout the entire building. But they have to be secure from theft, or absolutely nobody is going to use them. It's good if they've got some form of passive ventilation in. If something goes wrong, we do not want electrolyte gases to build up within a confined space. If they have a power supply in them, so people are plugging in and charging, make sure it's fitted with an RCD or some form of safety mechanism in there. As I mentioned, time-limited charging can sometimes be good. So if someone plugs in, they get 3 hours or 4 hours of charge, but no more. If there's smoke detection in there, it's fantastic. A standard smoke detection will pick up the off-gassing from a battery pack. A visual or an audible alarm is sometimes good as well. So if something is going wrong within the aggregated bicycle charging area, it's good that other people know that something is going wrong. A clear means of escape. You don't want to become locked in there with a bike or an e-bike going into thermal runaway. And clear instructions of what to do in the event of an alarm activation. This is quite important, because if you have a confined space and you have electrolyte gas building up into it, and someone comes along and opens the door, the inrush of atmospheric oxygen will actually cause the vapor cloud to ignite and explode. And the rule of all kind of explosions, it will follow the path of least resistance, which will be the open door with the person standing in front of it. So this is why on large battery energy storage units, you never open the door to extinguish the fire. Typically, you actually let it burn and just cool the area around it. So, we need to understand that if something goes wrong, how are we going to manage the risk and the early warning signs within that aggregated e-bike charging facility? If we look at basements, lots of basement structures I look around by default have good little areas or pockets or corners for putting bikes in and actually charging bikes. They can provide good areas because they're transient locations. People tend not to live, in the basement. If you look at the way they're constructed, by default, most of the walls will have a minimum of 60 minutes fire resistance built into them as well. And they can often be modified at a relatively low cost. So you might have a nice little corner like this. You may have like a corner with two sides, and just dropping a blockwork wall in there, doesn't have to be a structural wall, really helps trap any spread of fire just to contain it within the e-bike charging area. So a lot of the solutions for aggregating the charging of e-bikes and mobility scooters don't have to actually be expensive or complicated either. We do say outside is not always best. So lots of people just say, oh, we'll shove it outside, it'll be fine, because outside often means that someone's just charging it outside their front door, which could also be the only means of escape. So again, a lot of insurance policies say charge outside. Well, I think we need to go a bit further than just saying charge outside, and we need to be specific about what a safe outside place is. So if I look at that, the first image, fantastic. That's a wonderful outside space. There's no door and there's no windows. If you look at the second picture, yes, it's outside again, but next to a set of UVPC windows. So we always say not all external walls are equal. UVPC windows rapidly fail when exposed to fire, allowing the glass to drop out, which then allows the fire to move in. So again, I think it was initially the National Fire Chiefs Council were quoting 6 meters as a recommended distance, and a lot of insurers say 6 meters recommended distance if you're charging a bike or if you're charging a vehicle from a wall. I always say, look at what the wall is made of first of all, and look at what the function of that wall is. So it's a little bit more complicated, and sometimes these very simple sweeping statements can actually leave more margin for error. So I just really wanted to kind of like summarize the points that we've been through, and that lithium-ion fires are fast and they're toxic and they're explosive. So it's more than just fire hazard. Incidents are rising sharply and they don't really show any signs of slowing down. Many fires involve poor quality chargers or modified batteries. And fatalities are often a result of where the device was being charged and stored. So how can we improve this? Awareness is absolutely key to prevention. Safe charging practices reduce risk. And aggregated e-mobility areas may reduce the spread of that risk throughout a building. So instead of having it in every single apartment, not everyone may use the aggregated facility, but even if 30% of the people did, it's lowering the kind of risk throughout a residential building. And, out of sight cannot mean out of mind. And this just comes from a fantastic conversation we had in one high-rise luxury apartment block, again, where they said, we have a blanket ban on e-mobility device charging in our basement. I said, fantastic. Where do your residents charge? They said, in their rooms. And it's I would rather have had them all in the basement. So, out of sight cannot mean out of mind. Okay. I hope that's given everyone a kind of a tasting of where we are, or what we're looking to achieve. And please, if you have any questions, just let me know.
Yeah, I think that was really interesting. Thanks, Graeme. I particularly found it relevant talking about different types of wall. I have these conversations a lot. 6 meters is good as a general rule of thumb, but yeah, some walls, we happily put a scooter right up against it. If it's a gable end, there's no real risk there. So it really is about looking at it, case by case. So it was really interesting. That's great. And we do have a few questions on here. There's one quite specific question from Jackie Runnels was asking, in a lot of new build houses that she works on, they have open plan kitchen and living rooms. And what would be your advice on
Well,
where to? Yeah,
it's site specific. So again,
Yeah.
I err on caution of generalization. If there's a smoke detector at any point in that room, get it as close to the smoke detector as you possibly can, and just be mindful of where that room sits in relation to the escape route from the premises as well. Especially if it may be, it opens, the front door opens straight into that kitchen dining area, then that effectively is your only means for escape as well. But we really say to people, risk assessment is site specific, because every single building or apartment may be laid out the same, but people will use them all differently as well.
Yeah, again, it's that site specific business, isn't it? We've got a few more questions coming through now. One thing that was kind of mentioned right at the beginning, and I know lots of people will feel this, there are a lot of some people say illegal scooters driving around. David Gould was asking if he feels like the local authorities are taking this seriously. And I think they are taking this seriously. But what do you think is the main holdup, I suppose? Because that opinion that it's not being taken seriously, I would say, is quite held by a lot of people. But it is being taken seriously, as we know. But what makes people feel like that?
I think the last statistic I saw was every other e-bike in London had been converted illegally. So
Yeah.
it's a massive problem, and simple. It's always difficult to spot, and it's probably difficult to enforce, and that may come down to a lack of quality legislation, but more than anything, probably a lack of resource, as well, to really police this. But we see, well, I do a lot of risk assessments for police authorities, and I do see, the problem they have is, where do they now store all of their impounded e-bikes and e-scooters that have been modified? So there's a huge knock-on effect to where we're storing all of these. But when I go around and do my work with different police authorities, yes, lots are being taken off the streets.
Yeah, one question from Paul Spargo, which is something that I hear a lot, is Paul's concern is mainly around mobility scooters rather than the e-bikes, and more about how do you manage it where a tenant has had it for their entire life, there isn't anywhere for them to necessarily put it, and budgets don't allow for a room to be fireproofed, etc. What do you find is the best kind of way of approaching that? I suppose this is more about behavior and understanding risk than anything.
I mean, Gen 2, the Housing Association Gen 2 did a fantastic engagement process at their at some of their residential premises, where they, start off the process of trying to find out actually where are they, who has one, who doesn't have one. And then it tended to be, a knock on the door and just a conversation to say, we just wanted to make sure that you're maybe charging it in the best place. You're not, and it allowed them to have a conversation that was based about concern about their safety. It wasn't kind of very dictatorial, you must do this or you must do that. But that was a great approach by the team at Gen 2, which really seems to have worked. And then with any premises, it may be you're choosing the least bad option, so maybe someone is charging it in the absolute worst place. You could then move it to a slightly less worse place, but it still won't be ideal. But you've made an improvement somewhere.
Yeah, excellent. I think a lot of people feel like they know a lot of this, but actually it's really good to reinforce it and get back into the detail. Lee asked, he says, I assume that manufacturers' instructions would advise on the relevant installations for e-chargers for scooters, bikes, and cars. Other than this, is there any other overarching guidance or reference?
Yeah, so in terms of legislation, not much. There's massive guidance out there, and there's almost that challenge of there's so much guidance out there. Where do I go to? So I know the Electrical Safety First team produce really good, simple guidance, because I think the reality is if you buy a bike or an e-scooter, how many people actually unravel the manual and read it in almost the microscopic print that is printed? And people don't. They get all excited and they find a plug and they plug it in, and that becomes their charging habit for the rest of the relationship with that e-mobility device. But Electrical Safety First, I knew, do have some really good simple advice to follow that you can apply to everything. I think the key thing with the charging is making sure you're using the charger that was designed for that battery pack.
That's great. And actually a question just popped up which I was asked just, I think, yesterday or the day before. How much less at risk of thermal runaway are battery-powered devices when they're not charging, i.e. is most of the risk related to them being charged?
Okay, so I don't have the statistics for that for e-mobility devices, but if I compare it to electric vehicles. So if you have an electric vehicle, there's approximately 20%, a 1 in 5% occurrence of all the fires we've had, 1 in 5 or 20% have occurred while the vehicle was charging or within 1 hour of it charging, which actually means the other 80% happened somewhere else. But that could be because they were damaged, because they were dropped, because they've been involved in an accident, because they've gone through a fall, they've got water in them. So that could be the reason. But typically with an electric vehicle where we've had a thermal runaway event, it's 20%, 1 in 5, whilst charging or within an hour of charging.
That's actually kind of lower than I would have suspected. So that's interesting. And a lot of people have a no charging overnight policy. I suspect that may be based on the theory that they are affected more whilst charging.
Yeah, but it would be good to know how that's enforced.
Oh yeah, I mean, it's very, very difficult. And I think anything behavioural is what most people find a big challenge. Yeah.
I think you may have a higher statistic with e-bikes and e-mobility scooters because obviously a car has a very complex battery management system as part of the setup. Bicycles and e-bikes tend not to.
Okay. That's great. Thank you. What have we got? We've got 3 more minutes. If anyone wants to put up their hands and just ask a question directly, feel free. Should manufacturers be obliged to supply items with fireproof covers, which might suppress during idle or charging times?
So if you're talking about should the casing be fireproof to the battery pack, the problem you have is when the battery goes into the thermal runaway, the liquid turns to gas, and the gas creates a massive pressure. So the kind of it's always going to rupture and break and emit the gas. And once it ruptures and break, that's where the fire comes. So I don't think you're really going to probably, in terms of affordability, create almost what we would call it an indestructible battery pack in terms of weight, in terms of cost. I don't think that would ever happen. Whereas you can buy safes and special boxes for charging in, which are designed to deal with the battery when it goes into thermal runaway.
Brilliant. Kevin, did you want to say something there? I saw a hand up.
Hi, Graeme. Yeah, that was my question about the fireproof cover. Firstly, thanks for your presentation. I was more thinking something along the lines of, you sometimes see mobility scooters with a weatherproof cover so that people can park them outside, and I just wondered if there was an opportunity to have a cover like that they could put over their scooter, which will predominantly have the battery in the scooter, and then that would allow a little bit of kind of prevention on that part if it was plugged in and charging in a property.
So fire blankets are very interesting, and I've actually had this conversation with Fire Cheap Global, who I think they develop a fire cover that goes over shipping crates, which could easily be repurposed for mobility scooters. So fire blankets, I think, are an excellent tool in dealing with a lithium-ion battery fire, but they're not a silver bullet. So yes, it may stop the spread of fire, but the problem is if the battery's sort of gassing, you can actually then create an accumulation of gas underneath that blanket, de facto turning the blanket into a potential explosive, kind of atmosphere as well. So they would potentially reduce the spread of fire, but conversely, they may increase the risk of explosion.
Brilliant, that's great. That's all very interesting. So we'll have to stop there. Obviously, it's 12 o'clock, but Graeme has said he's going to go through the chat. We've got all of the questions. Sorry if we missed any of them, which we have missed a couple. But any that haven't been answered, we can respond. If you want to email us or Graeme directly, that'll also be great. And I think that's it. So thanks so much, Graeme. Well, I found it really interesting. And thanks everyone for attending.